Hello.
Thank you.
Yes.
I would like to invite the next author, Mrs. Anjali Pise, to present her paper on K-mean energy efficient optimal cluster based routing protocol in vehicular ad hoc networks.
Hello.
Uh, yes, sir. Good morning, one and all. I am Mrs. Anjali Pise, is presenting on mean energy efficient optimal cluster based routing protocol in vehicular ad hoc network. Huh. Sir, the contents of my presentation are the introduction, literature survey, proposed methodology, results and discussion, conclusion and references. Very first, the introduction. Vehicular ad hoc networks, that is VANETs, are special kind of mobile ad hoc networks that are formed between moving vehicles on an as-needed basis. Ad hoc means a system of network elements that combine to form a network when necessary or needed. Two main types of vehicular communication system are vehicle to vehicle and vehicle to infrastructure, that is V2V and V2I. Both these are ad hoc in nature. VANET is an emerging technology which enables a wide range of applications, including road safety, passenger convenience, infotainment, and intelligent transportation. Vehicular sensor network is made up of number of devices which are capable of sensing, processing, routing, and communicating. The information received from different nodes is used for monitoring and control of various applications, example, vehicle tracking and detection. However, the VANETs are fundamentally different to MANETs, such as the spatial mobility pattern and the rapid changing technology. This key differentiation causes the existing routing protocol on MANET, which cannot be directly applied to the VANETs. So the challenges in VANET are routing, security framework, broadcasting, and quality of services. The routing is the in the VANET is the key issue. The review of literature, some papers are reviewed. As an example, the Tang Cheng published a paper on addressing spectrum efficiency through hybrid duplex UAV communication challenges and opportunities. In this paper, they presented a review on recent advances in UAV channel modeling for HDD UAV communication. The Carolina and others presented a paper on survey on routing protocol for vehicular ad hoc network based on multimetrics. Here they concluded that the link stability, position, density, and speed are the most promising metrics in routing protocols for VANET. Masood Ahmad and others presented a paper on state-of-the-art clustering schemes in mobile ad hoc networks, objective challenges, future directions. They have analyzed their methodology for mobility model, the simulation tool used during that simulation, and the simulation matrix. Ikram Ali presented a paper on authentication and privacy scheme, that is they presented the aspects, those aspects which are concerned to the VANET security and the performance efficiency. Mahadev Gavas and others presented a paper on novel selective cross-layer based routing protocol, and they have done the paper or proposed their work on the applications like two-way traffic, road intersections, and analyzing the live GPS map efficiently. Nazia Hussain and others presented a paper on attack resilient and efficient QoS-based GPCR ARE protocol for VANET. The average delay was quite low and packet delivery ratio is also very low in their proposed methodology. They concluded this point. In my proposed methodology, I have concentrated on K-mean clustering technique. The routing protocol is designed by using the K-means clustering. That is divided into three phases. The phase one is nothing but the initialization phase. The second phase is the formation of cluster, which is again subdivided into four steps as calculation of K value, computation of distance, computation of new cluster center, termination condition, and the phase 3 is nothing but the selection of cluster head. In initialization phase, the sensor node in the network field receive that broadcast message as an initialization request from the sync node at the start of the network field. The reply message to the sync node should be provided by the surviving node, which is referred to as initialization reply message, that is IRP. The IRP message also contains information about nodes such as location of sensor and the amount of energy consumed by the devices. The cluster formation of cluster is the technique which is already known as a k-mean technique, in which the first of all, very first, the k-means or the value of the k is calculated, that is the number of clusters are taken. Then the distance is computed for each node with the centroid. New cluster centroid is formed by using computation of the and when in that particular cluster, if there is no new cluster center formation, then the step or the process is terminated. This is done in the phase 2. The phase 3 is the selection of cluster head. In the selection of cluster head, by using this k-means clustering, this is the very critical step in which the clusters are generated as a result of two phases that we have gone before. Following that, a cluster head might be selected from among the clusters during this phase, and that cluster head can be chosen by using two different weight functions. By using these three phases, the cluster head is selected. Whatever the nodes are taken, that nodes are evaluated by using three different metrics. Very first is the throughput. The throughput is nothing but the accomplishment of acknowledged packets via communication channel, which can be characterized as the throughput of the communication channel. The second evaluation metric considered is packet to the delivery ratio, that is PDR. It is the ratio of comparing the number of packets delivered properly and correctly to the number of packets delivered across the communication. The third one is the energy consumption, in which it is referred as the total amount of energy consumed during the transfer of packets from the source to the destination. All these three evaluation metrics are computed for number of vehicles as 50, 100, and 200 for the proposed system and the existing systems. And it is found out that the proposed system gives us better result for the throughput, then the packet to delivery ratio, and the energy consumption. The conclusion is it is one of the most demanding application on the VANET, and it is widely regarded as the most effective method of implementing it on the VANET because of the reduced travel time. VANET encourages people to be healthier, more tranquil, and more joyful in their lives. In this paper, we study various conventional and machine learning algorithms for VANETs. Also, we analyze the k-mean clustering algorithm for energy efficient routing and cluster head selection. These are some references. Thank you.
Okay. Uh, Umar sir?
Yes,
Yeah. Please go ahead, sir.
yeah. Thank you very much, madam. Uh, so, what is the main purpose of your this article, this um, VANET routing protocols? What is the main purpose?
So to avoid the accidents, we need to send the messages to the vehicles within zero point 0.5 seconds. Number of accidents occurs because of the if the message is not going towards the other vehicle in due time. So if we are able to give the message that there is some problem ahead within zero point 0.5 seconds, then that accidents may be avoided.
So, how to avoid it, madam?
Sir,
So,
we
it
have
is what I am asking. This paper only for a survey paper, review paper, or Any implementation you can done, you can already done.
Sir, just I have started with the implementation. The complete implementation is not done till date.
Yeah.
Actually, the messages we are going to transmit, we are going
Why?
to run that nodes in such a way that the message will be transferred in due time.
Okay. Based on this concept, already we have a lot of different type of research, existing research paper. So what is
Yes,
the difference between existing one and your side, in your paper?
sir, we are going for one more efficient algorithm as HROA, that is a hybrid ROA algorithm,
Hmm.
which will give us better throughput, better delay time, uh, better outputs in all aspects.
Okay.
I'm
So
working on that.
how you get all results, madam? You are using any specific software?
Sir, NS2, Network Simulator.
Hello.
Hello. Sir, Network Simulator I am going to use.
Yeah, network simulation. Which version?
Second,
Version one, version two, three. Which
NS2.
one?
NS2, sir.
NS2.
Uh,
Okay. So how you consider this node? Because you already mentioned that calculation of k values, selection of cluster head, termination conditions, different parameter you consider. So my question is selection of cluster head, how it is formed?
Sir, first, the different nodes we are going to generate, and by using that nodes, one centroid is taken, and then the distance is calculated with respect to the centroid with the other nodes, and then the whatever the least distance will be there, the centroid will be found out, and that will be your cluster head.
Okay. What about termination condition?
Which, sir?
Termination condition. You mentioned that the termination
Termination
condition is
condition.
there.
Sir, when
Yeah.
the new
Yes,
then
please.
then the process will be terminated.
Sorry, once again, please.
Sir, continuously the new cluster center we are going to compute.
Hmm.
When a new cluster center is not formed,
Hmm.
then the condition is terminated, or that step is
So
terminated.
when new cluster is not formed, automatically the termination condition is generated. As
Yes,
per
yes,
your, that is correct.
yes, sir.
Oh, okay. So what about the calculation of k value?
So, sir, K is randomly taken at the start. Actually, that equation will be there as K is equal to under root of n by 2 pi
Hmm.
into under root of f by x sn square, where that xsn is nothing but the normal distance of all sensor nodes to the sink node, and f is
Hmm.
described as the dimension of created network structure, and n is the number of sensor nodes in the network structure.
Okay, what is my final question is any drawback of drawback in your paper?
So, sir, just we have started work on that. So right now I am not getting any drawback.
Yeah, so there is no drawbacks in your article.
No, sir.
Okay, thank you.
Thanks.
Thank you, sir.
Okay, sir. Okay, sir. Shiv Kumar, sir.
No, sir.
Hello. Yes.
Yeah. Shiv Kumar, sir.
Student, actually, what's also Anjali, right? Yes.
Yes, yes.
Anjali, while presenting, you just make a presentation mode, right? Make it full screen, first of all. I mean, clear.
Yes, sir.
Anjali, am I audible? Hello, author.
Yes, yes. You are audible, sir. Madam, can you start slideshow?
No, whenever you are presenting, you just make it full screen, first of all.
Yes.
Then only it is easy for us to understand everything.
Actually, I have made
Please,
full.
one more point. One more point. Please don't read PPT. So next participant, I request you to Please don't read PPTs. You explain PPTs. You concept explain.
Okay, fine. Okay. So you have used K-mean clustering, right? I need a response. Hello. Can you respond?
Yes, sir.
Yes. So any reason behind that? Why you are choosing that particular K-mean clustering algorithm? Why didn't you go for another algorithm?
Sir, I think it is the most efficient algorithm.
How can you say these things? If
Sir,
you compare some algorithm, or if you know some other algorithm, then only you can come to this conclusion, right? I'm just asking, what is the reason behind that for choosing this particular algorithm?
sir, K-mean clustering is a popularly known algorithm in which the cluster rate selection is very accurate.
Okay. Okay. How many papers you have studied? Sorry.
40.
40. Very good. Very good. Okay. Good. Fine. Thank you.